Okay, just a couple of words about the Data Engineer Milano Meetup. The Meetup is now 2 years old, some more, but almost, let me say 2 years old. The Meetup was created to create a community here in Milan of data engineers, or in general, people that work with data and data lover, like I love to say. The idea is to have a place to together to share experiences and to talk about a topic related to data management and data governance. The first meetup was organized physically in physical location, and then comes the COVID, so we are now with all the event in a virtual setup like today, but we hope in the near future to return to organize some physical event to see each other face by face. The meetup was created by me and some co-worker of mine. We all work in Quantica. Quantica is a company specialized in data metadata management. Just one slide to mention Quantica because it's the main sponsor of the meetup, so basically sponsor the page on the Meetup website and all the work that we as organizer do to organize all this event, talk with the speaker, and organize everything. So just a mention is a must. The meetup, of course, is open to all kind of contribution. Mainly, if you want to propose a talk, we are very happy. You can drop me an email, and we can organize. But we feel free to write me an email if you want to contribute. So in some other way, so we can talk and see how to organize that. Of course, one thing that everybody can do to contribute is to spread the word about the meetup. I invite some friends, some co-worker to our event, because the bigger is the community and the bigger is the audience, more simple is also to attract a speaker with interesting topics, and so would be better for the community as a whole if we increase the number of subscribers. Say that, I think that we can start. So I leave the stage to Andy. As I said at the beginning, he will show us how to do data observability in the right way, explain a methodology that contribute to design and the key principle behind this methodology. We've also, I think, some demo or live coding. So I'm really excited to see what he's going to do. So Andy, the stage is yours. Do whatever you want.
Fine. Don't get me started. So I like to do a lot of things. So I try to keep focused and concentrate on the topic of today. Let me share my screen, at least this window where I have my slides. Can you see my slides? Okay, so Meet is actually showing me.
Yes, we can see it. At least I can see your slide.
Okay. So I can see them too. So that makes two of us. I hope that the others also can see the slides. So actually, okay, so Meet was showing me something. So we're going to talk indeed, as introduced Andrea, about the data observability, and especially about a method that I had, been sharpening for the last 5 to 6 years, based on experience in data management, data monitoring. But first, I would love to thank you for inviting me to this meetup. Milano is a city that I love, so this is where I have built and created this R&D team. We're supporting the development of the Kensu platform. So that's why it was important for me to participate to your venture in this meetup. So I'm really supportive of this kind of initiative, and I know it's hard. So thank you, Andrea, for this effort that you're doing, and thank you everyone for attending this meetup, dedicating your valuable time to listen to the topic of today, which I introduce as data observability driven development. A few words maybe about me. So just really quick, like so you know who I am and why I'm here and why I'm so enthusiastic about data observability. So long story short, I have a background in mathematics and computer science, and I've been a data miner, data scientist for almost 10 years before I jumped into a role of freelancer around the 2010 when I started using Spark to do distributed machine learning, especially on genomes and on geospatial information. And because it was super early and I needed a lot of tools in order to do my job properly, I started working on an open source project that became relatively famous at this time, which was the Spark Notebook. And this led me to work several years in the Valley, where the Spark Notebook was used heavily by big brands over there to do and start and get it started with Spark, where they were starting using less and less Hadoop in favor of Spark for even machine learning. So that was a great time. So I published many books, and then I grew this community around Spark, the data science, distributed, and so on and so forth. But with this explosion of interest in data, AI, notebooks, and operations on data and machine learning, I also detected in the mid 2010s that there is something that will happen. That's something that I've suffered from, which is it's cool that we can faster and faster go to production, so to speak, with data and data product and data applications. But there was nothing really to help us making sure that we can still trust what we deliver. So that's how I got started with the company Kensu around two things. First, it was a method that I have developed over the years in how to create trust around data and machine learning models and stuff like that, and the platform that was missing back then and still now in order to fulfill the gap in architecture overall when it comes to data. And this is data observability. So the latest publication I've actually wrote, and they both were for O'Reilly. So last year I wrote about what is data governance, the business impact. And this year, actually, when I say this year is this week, when I say this week is today, actually I released this new book with O'Reilly. This time we supported about what is data observability. So you can pick it up on our website. Where of course I'm going in a bit more details about what is data observability in this book than I will go today. Today I will try to focus on the few concepts that is important for data observability and how to introduce it at the time when you conceive applications, and I give a few examples using Python and some SQL. So okay, data observability. Let's get started. First, for me, it's important to distinguish data monitoring from data observability, because there are data quality monitoring from data observability, because they are two things that are quite similar and they can play together very well, but they are pretty much two different things in a way. So they can live together in the same architecture, to be honest. The idea of data observability is to enable faster detection, resolution, and prevention of data issues. So the resolution and preventions are key for data observability, because they are very what actually they can add in a data platform when it comes to data quality monitoring. So what is important with data observability, I don't know if you heard that, but it's really about detection, resolution, and prevention of data issues, right? And the very first one aspect that I wanted to cover is detecting data issues can be done with automation of data quality monitoring, which we conceive generally as scanners. This kind of action that we were doing in order to check data quality constraints like completeness, timeliness, etc., right? Can be, so these constraints that you can consider as service level agreements between the consumers and the producers. These kind of constraints can be considered as service level agreements, as I said. But these constraints and this kind of discussion that is happening between the consumers and producers are not beneficial if you're not capable of producing some indicators. And the indicators are these information that are gathered from the data in order to see if to actually evaluate these constraints. So if the data cannot be older than a week, then you have to check, how long, how old is the latest data in your data set by checking, I don't know, using an SQL select max date in update time, for instance, right? And you check that this max is not more than a week old. These kind of actions are generally made in order to check the data quality when the data is available somewhere, and you want to check if it is currently matching the expectations. However, being able to, so that allows to detect data issues, of course, because you have the indicators and you have the constraints, right? But if you do it only at the end, mainly when the data is available in production, that you have deployed your applications that is producing this data, whatever it's a Python code, Spark, SQL, whatever, right? Then these manual checks that you may want to automate by creating scanners that you are continually running using a scheduler, whatever, right, have a lot of pitfalls. The two major ones is that this kind of automation of the data quality monitoring activities, again, the scanners, right, happen in a different process. So you go on production with your application, with your SQL, whatever, right? And then you have to introduce an extra step into the process, which is creating this kind of automated manual data quality monitoring activities. So it's a bit outside of the delivery, or at least an extra step that you must not forget. And generally, as data engineers, we are not even part of the solution, because we tend to delegate that to other people, which is a huge issue. The second one is that automating by running periodically this kind of checks, right, require that you need to align as much as possible these checks with how the data is being used and at what time you want to detect issues to happen. And this is a big one. It's a big one because if you consider these three different timelines, where you have the data application timeline, and you have the data timeline, for instance, the data application is running, at a various time, of course, because it's not meant to essentially run in a periodically time frame. So data are produced every time the application is actually extracting data or performing aggregation, or in a ad hoc fashion, right? And some issues are happening. When I see issues, some data are not respecting some of the SLAs that needs to be respected to create some reputation on the data set of good usage. So here, for instance, you have an error, and you will not be able to detect it before the data quality monitoring timeline has triggered the check of the quality. So here, every time there is a check, so it addresses the data, it checks SQL, and again, so it can be whatever that is checking the quality of the data by reading it and performing some actions. But here, the thing is that, so you will discover it quite late, of course, because there is this period where the data is wrong, at least until the next execution. And also there is another execution that has changed the data, basically, right? That may impact the visibility that you have about this error there. You can have mutation, you can have new rows, you can have so many things that will disrupt actually the visibility that you have about this specific event. The next one is, if there is an execution here and there is nothing happening for a certain period of time, you may have also execution that are actually totally worthless, because basically nothing is happening. So there is no point in reading the data once again in order to produce extra metrics. So these are some of the pitfalls of automating. When I say automating, is like activating a battery of scanners that you have to organize and schedule and maintain. So this is the third pitfall. This is the third consequences of introducing scanners. Is this yet another thing that you have to maintain and productize? An alternative is to, like in observability, is to pay attention to certain KPIs. Observability is something that is recovered, I would say, from IT, and IT itself has taken it from different area like physics. But observability in IT, for instance, has defined several KPIs that are very important to control and using observability. One is ensure a minimal mean time to detection, which is the average time needed in order to detect something that has happened, right? So if something happened at T0, you want the detection time to be as close as possible to T0, eventually in real time. Therefore, when you consider, these kind of scanners that you are activating on the data at a certain periodicity, right, are something like workarounds, right? So you deploy the data, and after the fact, you want to do something in order to recover a little bit of visibility, of quality visibility too. So, and there is something better that could be done in order to make it a little bit more close to what has been introduced in IT observability. If you know Splunk or Datadog or Dynatrace and stuff like this, you have this kind of notion about embedding this the information needed to understand how an application is performing within the application. In this case, because data is never created manually unless in the input, right? But is never creating the pipeline manually. There is always an application, right? When there is an issue with the data, you can never change the data manually. There is always an application that you have to run or configure in order to recover the situation of the data, and they put it at a better quality level, right? You need to understand which application have actually created the issue in the data, right? So what you want to do in order to reduce the mean time to detection is to detect the error when it is actually being created. And because the data are created by application, right, the application at runtime can generate not only, you see here we have swapped the data, the timeline. So we have the data application, which is at the center of the solution, right? And the data application is pushing first the data into, let's say, the database, but also it is capable of pushing some information about the data quality itself, because it had the quality, it had the data at hand, it dropped it to the database. So it can also at the same time produce some information about what it is currently doing with the data that can report it to the data quality monitoring timeline, right? So actually the application has the power and at runtime and the capacity to create these things. So that means that you introduce low latency data profiling and the gathering of loggings and metrics needed to identify the issues. That means matching the SLAs. That reduces a lot the mean time to detection, and also it allows the system to be efficient because there is no need of running external application accessing the data when it's not needed. The data is actually not being accessed for the data monitoring because the application is only pushing the information about data in real time. So it's a little bit flipping the concept, the angle at which you look at the problem. Instead of looking at the problem of data quality from the data angle, you can take a look at this problem from the data application perspective, right? So meaning that you can leverage the fact that the applications can produce extra information about the data. So the next topic, so I'm looking at my clocks and try to go fast in order to go to the demo. So I'm still there. You can still hear me. I'm going to check now every 3 or 4 minutes.
Yes, we can hear you.
Yeah. Okay. I'm going to scan you guys.
It's right. Sometimes you can do a check. It's better. It's a check.
Okay. Because in Meet I cannot see you, so I have no visibility. So I'm a little bit stuck. When it comes to resolving, there is a big an important aspect of data quality, which is hard to address without data observability, is the root cause analysis. Because data quality is important, it's capable of identifying, data issues, right? But it's not conceived in a way that it can easily create a context that will allow the data issue root cause to be identified faster, right? Relatively fast, because you know that there is a problem in the data, but you have little information about how this problem has happened, from where the data was coming, where the data is going, etc. So you lack a lot of information that are contextual to the what I call catastrophe. So it's a catastrophe due to the data, right? In order to identify where the problem has initiated and how you're going to fix the situation. Nevertheless, when you are capable of identifying data issues or catastrophes, you have to first, of course, communicate that there is an issue with the data. So people that were using it shouldn't use it, or at least in full awareness and wisely, right? But also you have to find a solution to fix the situation. That's the next task that needs to be done. And then the second one that everybody is going to ask is, okay, when is this going to be fixed? So provide a timeline. So if there is little information about why the data issues has happened, mainly what are the applications that needs to be fixed in order to resolve the situation, it's actually insanely hard, right? So I've been there, and I guess you too, right? It's hard to understand, okay, where the data is coming from, especially, well, I mean, when the code has been created like months or years ago. So as I said earlier, we cannot fix the data, right? We cannot fix the data itself. We can fix something that is producing or something that is consuming the data, right? So the data is the data. You don't go in the database and change it manually. You need to run something that is going to change the data by changing a business rule, whatever. So I'm coming to that point. So there is always, I've never seen any other cases, there is always an application that needs to be identified to fix the data issue. It's not manual. That's why performing root cause analysis is critical in data management nowadays, essentially because also we have many more data processes running in different places. We have made way more people educated to run data pipelines. So that means that we have way more instances of this kind of issue to be resolved. So that means that we need to be fast at also finding what are the root causes. So really fast on that thing, on that slide, of course, the slide we were provided, so I'm not going to read it through, but there are many different cases where causes of an issue. Of course, there are manual inputs, system failures, etc., right? But there is also simply the fact that the data is changing by nature because it's representing the real world. That means that some data have changed because the world have changed, but it may imply some consequences on the way you were conceiving the world and the way you were computing some KPI, business, whatsoever. That's specifically true for retail, banking, and financing, for instance, citing only those. The data semantic can change sometimes, for unexpected reasons. And sometimes maybe only it's just a bug, right? Because the business logic that were anticipated, right, or conceptualized before was not actually right or has been wrongly implemented. So there is a bug basically that needs to be fixed that is creating this issue. So these are different stuff that can happen and needs to be identified, and a solution can have to be provided. So very quick, root cause analysis. You depart from the data like the BigQuery data that is on the extreme right. So the idea is that with data observability, you have to recover, as I said earlier, information about the quality of the data, as much possible close to the event, so low latency, synchronized detection of the issues. Then you need some extra information, which is the lineage, in order to understand where the data is actually coming from in order to identify the problem, right? So if you start from the BigQuery, you need to have the statistics, then you start performing the root cause analysis, you go to ORC. So as long as you have the lineage, you know that you have to go to that ORC, look at the data or look at the statistics because you have them due to the profiling. Then, okay, it's not in the RC file. Then you can go to the MariaDB, you look at the statistics, and you can check the JSON, you can check the Excel, and then you can find out ultimately that the problem was in PostgreSQL, for instance, because there is a definition of data that has changed, and it has not well been reproduced and propagated in the network. However, it's cool that with the lineage you can do this, but it's not enough. Right, the lineage, which is one of the dimensions of observability, which is added in the context of monitoring of the data, right, is not enough, because lineage is just connecting data together, right? In order to solve a situation, you need to know where the data is coming from. So, is it where in the middle of this data manipulation is the application or the applications that needs to be adapted in order to clarify or to raise the level of quality of the MariaDB and ultimately, of course, the BigQuery. Do we have to update an extra application after MariaDB, or solving the situation of the MariaDB is enough? So, for instance, the PostgreSQL, it's a real case, where you can have values represented in unit at some point, and the salesperson, for reasons that might be good, right, have changed the way they were imputing consumption, right? So consumption of some services, not in units anymore, but in thousands, right? So that means that you divide by thousands, but it was missing, not propagated properly, and then actually everything is disrupted. So how can you perform this kind of root cause analysis and then provide a solution and in a timely fashion without information about the application? So what I'm proposing is, instead of only having the lineage, which is interesting to do the first part of root cause analysis, but not to finding a solution, is to add the information about the application in the middle, right? So interestingly, you can actually gather information of the application themselves consuming and producing data. In this case, you can have, of course, SQL dumping data in BigQuery, reading data that were created out of some applications like Spark, Talent, Python, etc., etc. But this information is interesting because then your root cause analysis can be structured and faster also executed. So you can go from the BigQuery and look at the application that is producing this type of column that is currently filling directly. So you know that there is a SQL that is filling this. From the SQL, you know what kind of data is used because this is the MariaDB. From the MariaDB, you know which application have produced a column that is actually filling in the BigQuery, so you can jump directly to the right application, which is taking care of filling this column in MariaDB. So in 2 steps, using the application as inflection point, so by reorienting your perception or your angle at which you look at the problem, right, is accelerating the root cause analysis first, but also the next step, which is identifying the application that you need to change in order to recover a right situation, is not needed anymore because you use this kind of artifacts in order to proceed already with the root cause analysis. And that's key. And that's one of the facts that I have built, around the recent years, right, almost 7 years now, in order to accelerate this kind of things, because when there is a data issue, that we have basically no time to resolve it, because as long as the business user or the consumer is detecting the issue instead of us, they come, they knock at the door, they yell at you because the data is not good, and they have spent already an hour trying to figure out what is going on, right? And they were expecting you to find out before. And at this moment, you can say, "Oh, I'm going to try to find out what I can do, etc." But it's always too late. Everybody's pissed off, so the trust is lost, and it's going to be hard to recover it, and we feel sorry, we feel anxious for the next project that we're going to deploy, essentially, especially with this person, for instance. So it is key to think that way in order to accelerate this kind of process, so that we can be more confident, and we can actually be more quiet and more confident when there is someone that comes and say that there is a there is a quality issue, you know that you have enough information about the system to find out. So what time is it? Okay. So I'm going to conclude on this for the small demo that I have prepared for you. So the last one thing that I wanted to explain is that it's important also to prevent bad thing to happen, right? So basically, because you started involving data observability, which is, as you understood, a little bit wider than data quality monitoring, which introduce lineage, application information, so synchronization, contextualization, etc., right? You want to avoid something called data cascades by Google, and there is a nice paper about it too, right? Which is avoiding that there is cascades, right? So there is a problem that is propagated in different pipelines and introducing problems in other data sets, right? So using application information and lineage information, you can anticipate which application may have to be stopped or reduced in order to avoid, you know, the so famous garbage in, garbage out, for instance. Right? And this is cool based on this information that you can do this, but actually we can even extend this kind of impact analysis and communication about propagation by introducing the concept of what I call also circuit breaker, because it's actually something that comes from observability in IT too. And this can be introduced during the postmortem, basically. So when you have an issue, the data is wrong at some point in time, you need to fix it. You find out what you need to fix in the application, which is, you know, considering the data as thousands. So, for instance, there you're going to divide by thousands, for instance, so the new data that is coming, multiply by 1,000 the data that are coming. And because you have updated this application, which is capable of producing information about the distribution of these values, you can also leverage this moment in the application when you create the solution to resolve the situation to be proactive. That means that you can still, within the application, test that the new data is still respecting the new assumption that you have about the data, which is now expressed in thousands. That means that maybe it's below 1 million or below 1,000, or that the data cannot vary more than, 15% rapidly, because otherwise it might create some troubles downstream. So this kind of learning and the new knowledge that you have about the way the data is conceived can allow you to extend the application capabilities with this kind of secret breaker. That is, okay, the data seems to be not good today. I'm going to stop my process instead of generating garbage out. Right? So this is something that is trivial and intuitive in IT when we check null values or negative values or something like this. But this needs to be also introduced in data. And there is a concept that I call a continuous validation, which is fostering this aspect, which is we have CI/CD, which is leveraging testing before going to production and validating everything before going to production. But with data, because data change over time in production without any notifications, so to speak, then you need to continuously validate that the assumptions that you have constructed around data are still holding true in production. And this is actually a set of processes and methods and culture aspect of the data engineering and data science activities, to be honest, that is also capable of optimizing something important in a data architecture, so to speak, which is or management. Is to minimize the number of issues, because you can avoid some garbage out, right? Because the application is not capable of handling some type of data, for instance. You avoid the number of issues, which are the data cascades, right? And propagation. That means less issues, less money, less time spent in maintenance, support, and stuff like that. And which is super important in order to increase also the ROI of any application on data. So Data observability dot, which is a way to embrace actually observability in a structured manner in organization, right? It's the reuse of some best practices that from software engineering. I've explained most of them already. As it's coming from TDD, test-driven development, or DDD, domain-driven development, and stuff like that, right? Actually, TDD, for instance, is a very fantastic concept, and actually, it was very nice at the time that testing was not very famous, so the reputation of testing was not that great. And with TDD, we could actually create some kind of culture, right? That writing test is good, right? It doesn't mean that there are a lot of people that are writing TDD code, right? So writing the code, the test code before the logic, because, well, there is also the constraints of time and productivity, and this is not naturally, intuitively effective enough to do it that way. But this kind of concept that are natural to everybody would say, yeah, it's a good way to work, right? I mean, it creates trust, it creates confidence. It's expensive, but it's fundamentally good. However, if they cannot play it, right, when they go to production without any test at all, there is some kind of anxiety that is created. There is almost shame that in ourselves that going in production without any test, at least in IT so far, right? Because we feel that there is something wrong with what we've done, right? It doesn't mean that we don't do it, right? It means sometimes that we have to do it, but we don't feel super, proud of doing it that way. And actually, this is something that needs to happen in data too. That's as simple as this. So think about, when you conceive your application, you think about the test, you think about your domain you build, you think about your behavior, think also about what you want to observe in the data, what kind of metrics you need to publish from the application in order to understand what's going on, what are the lineage are important to trace in order to ensure that when there will be an issue, you know how to find a solution. So with this kind of culture and method, you will at least by default in your application respect the two first principles, which are synchronization and continuization. Then there is the concept of circuit breaker already introduced. So with continuous validation and CI/CD. So we're good on that. So I'm accelerating a little bit. So that would look like this. So we have the different environment. We have the application code that will run in a different environment. So we have data observability embedded in the application. We have the test code. The data observability can check a rule like, okay, the age.null must be less than 10. The test check, hey, is this rule okay? Yes, then we deploy in Q&A. In Q&A, the tests are run also. We validate the rule here. If the test will assess that the rule has passed, well, actually not, it didn't pass well, that means that we cannot go in production. If it passes, everything goes to production. We don't deploy the test code anymore, of course, with application testing, but the validation rules are still happening in production. So this concept of validating that age.null is still less than 10 is continuously tested and validated in production, so that when it doesn't matches anymore, you will be notified. So that's the concept of CI/CD and CV that is great for data. Good. So I reached the point, okay, 8:48, but we started, so I still have 10 minutes, I believe, to do so. Is that okay, Andrea?
Even more. Take your time.
Even more. Okay. So 1 hour and 10 minutes?
Yeah, you can. If you need it, we are follow you, so you can take us some more time. Then at the end, we will be a Q&A. In the meanwhile, if someone have a question, can also write down in the chat, and then we will collect all the question.
Okay.
So
Okay,
take your time. Don't go too quickly.
Yeah, I'm pissed that I lost these 2 minutes. Actually, I don't know what I have missed, and finally, anyway, good. So for the demo, so there is one slide I wanted to show, so it demonstrate what I want to demonstrate to you guys. So this is the thing, right? I'm not going to do everything in the workflow this time, but actually, so the demo will use some files that are stored in Google Storage. So in the folder, in the bucket of workshop Kensu, And for each month of data, so we'll simulate the data which is loaded every month. So we'll have 3 different tables coming from, I don't know, SAP, for instance, that are dumped into CSV. And we have a referential data, which is, a small reference, a code, and then single, a code, and then a married, and a code, a widow, etc., that is stored over here. And what happened is that in Google Colab, I will write some Python script, which is going to do a small, very small and simplistic ETL, which is taking this data and dumping it into Google BigQuery. Okay. I will do it again for the contact, and for the customers, I will reconsolidate the marital status before creating the customer's data. Then I have also a workflow in Google which can schedule and execute an SQL query that is going to take the 3 table here and dump it into a kind of small data mart, or maybe this is still the data warehouse, customer 360 information here. And this SQL will be run here, and the piece of software which is running the SQL, mainly dumping the data into BigQuery, is both here and here extended with Dot. So both the SQL engine and the Colab itself is beefed up with Dot principles, which are collecting metrics, lineage, application information, project, and so on and so forth, so that visibility is granted. Nevertheless, there are a few SLA and SLOs, right? So SLAs are these constraints with the users, consumers, so to speak, and SLOs are mainly for the producers, what they want to respect for their own, right? There is no specific contract, but they want to control that for themselves. First, in the data in BigQuery should respect a constraint of completeness, which is the data that I have here. If I have 5,000 data here, I must have 5,000 here, right? So basically consider the completeness. And if there is a problem with this completeness constraints, then the data in BigQuery cannot be produced, right? Because basically it would be garbage out. The data cannot be used efficiently. There are other kind of constraints that we want to fix for ourselves, like we don't want to have many null values for a column that I explain afterwards, which is the marital one, and then we will see the other SLOs in the code. Okay, so a pretty simple process, right? So with a few technologies here and there, but the applications are only 2. So you have Colab, which is a notebook that I guess you know, right? And you have this Google function, which is only passing along the SQL to BigQuery to create the table from this 3 table. Okay. So I don't know if you can read this properly, because I'm a small machine, so maybe it's small. Can you read it fine?
I can, but I have a big screen, but I can.
Let me know in the chat if that is okay. And Andrea, if there is any request, tell me, because I cannot see the chat, and I will increase the font.
Yes, I think that it's okay for almost everybody. Yes, okay. Yes, you can go. We can read it.
Okay, good. So I'm connected to my machine. Okay. So Google Colab, right? It's like interesting tool, just a kind of wrapper for Jupyter, so that you can run it almost everywhere in their infrastructure. So what we've done here is that we're going to do the small ETLs with the data. So I have a bunch of code, and I will write the remaining. I actually said that I'm going to do live coding. I will do live coding. So what I've done here is that basically I have imported the Kensu library. As you can see, Kensu uses provider, and this library is going to publish the statistics, lineage information, everything directly to the server, to a Kensu server in this case. And the library here, this is a dot client basically that is available here in open source fashion. So KensuPy on Kensu.io -oss. So this library can produce metrics and lineage for pandas, as I will show here. And then I will import these 2 lines here, are importing 2 things. First, pandas, and a wrapper, not a wrapper, an extension of Pandas that is capable of dealing with Google BigQuery. Okay, but you might notice that Pandas has been prefixed by Kensu and this one too, right? Why? Because actually we use the original Pandas is installed, right? So actually I can show it, but what has been done in this DOD open source library I've shown earlier is that there is a series of monkey patching for the entire Pandas main functions, right? That is capable of tracking what is done with the data in order to produce the lineage and also produce the statistics about the input and the output of the process that is being performed with Pandas, right? When you read data, when you write data, there will be statistics generating on the input and outputs, and the lineage reconnecting the dots between the input and outputs is generating. Right, it's pretty much like reconstructing ultimately the DAG of the Pandas code in this case, and this kind of thing has been done for other languages like R or Java, using Spring, Hibernate, and things like this in order to get this kind of capacity. So I'm going to execute those. That is, I'm connecting to the server. Here I'm going to import the both libraries, and then I'm going to start by importing the January data, right? So this will help me reading the data in Kensu workshop, then January, then I have the dump of my January data for the business data. So here I'm reading with Pandas, right? January data, and I'm parsing the dates. The column load date business is a date column, so I'm parsing in the date. Then I'm dropping it because BigQuery is not capable of handling this kind of timestamp, but it's pure mechanics here. And if I read this, if I do this right, then I started my process of manipulating data. Okay, so now I can also, as I said, so here we're going to transfer the data naturally to the table. So I'm going to write it. Okay, so here pgbq is called with this function, this method here to gbq with the data frame and the target. So this is the name of the table in the project, this project, and if it exists, it only appends it, right? So here I'm writing. So here, this is the very first, simplistic ETL that I'm writing. So at this moment, the data is read and it is produced to BigQuery. So what happens is that I'm going to connect to the server, to the Kensu server, which is a data observability platform then, and there is a project that has appeared here with one application at this point, that is the data engineering Meetup collab, right? Which is and there is a L2 match here, which is the application that I've started here, right? And if I dig into this application, I will see the two data sets that I have been reading, the CSV and the data set that I've written, which is the big query table, right? And we see that this is the Colab notebook here that is running, and there is only one version so far because I didn't update it. So this is in the application Colab, right? We have the link between the data, okay? There is an extra information that I have, so I can navigate here to the data source, and I can actually check business data in this application from this project. I can pick some of the statistics that were generated for this table, for this data frame that has been creating this table. Here, you see that I have only one line with this value of Euribor, which is an interest rate. I have some quantized information and the amount of information which I not know. I have the max, the mean, and I have the number of the rows, and I have the number of no rows general, right? So that means here that we have no rows, as we can see here. So data statistics are generated directly, as long as with also all together with the lineage information. So what I can do too, right? As I said, so I need also to take the contact data and to create the table, right? I'm going to do it again, right? So I'm going to run this code, which is reading the CSV, parsing the day, removing it, and then save it. So the code is the same, right? Because we need to produce the table. I'm going here, I refresh, right? And boom, actually I have my new contact information, CSV, and the contact, and I have the lineage. Good. But we have this customer data that we have to merge, right? So here I'm going to do a little bit different, right? So I'm going to read the data like the others, and then I'm going to read the other file, which is the marital status v1, sorry, which is the very first version. I will tell more after why. So here I'm just reading the data. Customer and marital, so which are this one and this one, okay? So it has run. So what I can do now is that I have to combine them together, right? So actually I'm going to reuse the same variable, right? It's equal to the same one. So customer data is equal to customer data. I'm going to merge it with marital status, right? And the right column, so for the customer data, it's going to be marital. So the marital column is this one, and here on marital status, I have the left on. So on the left join, sorry, I have a marital status code, if I remember well, right? And we're going to do a inner join, right? So basically, everything that is not matching is going to be removed. Okay. There is one thing is that in the BigQuery table, these columns are not present. So because basically the consumer don't need this information, right? So basically, I'm going to remove these two columns, which is marital and marital status code, right? And then on the access one, because those are columns. Another thing that I need to do is, so I can show this data frame, of course. So marital status code, and this is the values, and this is the value here needs to be the marital value, right? So what I'm going to do is to rename this. Sorry, I need to rename the column value in the output into, well, it must be marital in the database, and it's going to be also the renaming of columns, so it's one. Okay, so here I'm just merging, like it's like writing my SQL, writing code, so everybody knows the pandas, I assume, or the link with SQL, right? So here I have an error. Of course, this is why I'm doing live coding, is because there is a live debugging too, of course. So here I have the schema, I have marital, right? And the other side, I have marital status code. So drop marital schema, and I have done something wrong. Key error, value, marital, x1. What did I miss? So generally during live session, this is where the audience is happy because they can help the poor, the poor presenter who has always a backup, of course, to avoid looking like stupid for too long. And actually, customer
I
data.
think it's the right on and left on that
Yeah,
have to
because
be.
I stopped them. See? There you go. I told you, right? The audience is always the savior. Thanks a lot. So here now I have my merge data. So what did I want to do? Okay, so I merge it and then save it here, right? But okay, so I know that I'm actually doing an inner join, right? So I know by experience that this can actually fail. So what I'm going to do before saving it, right? I'm going to create a constraint, right? So what I can do is that I can import from Kensu utils rule engine. I can import the n rows, check and row consistency, Okay, this function is going to create a rule how on maximum. So I want to check that the output of this thing has as many rows as the maximal of the input of the merge, right? So if I have several joins, right, I want to have as many data as I can, right? So this is creating a constraint that if it fails, right, is going to fail the notebook, right? So the cell is going to throw an exception because I want it to be a secret breaker, right? So here there is an SLA, copied and rows needs to be secret breaking this thing. Then I can copy paste here, right? Where we're going to save this data set, right? Here, so PGPQ, which is the client to say, the library for pandas of BigQuery. We send it to a workshop customers table in the same project, and if it happens, go. So am I still connected? Yes, looks like. So I can run this here to save the data. So again, so what did I do? I must have done something wrong again. So please verify the structure and data types of data frame match the schema of this table. So I may have done something stupid, which is indeed this needs to be status. Works. There we go. And then I'm saving it. Okay, so this is good. Normal, so I have to do it quick. You know, actually, what happens is that actually I didn't write the run column, so I screwed the the BigQuery table, but it's gonna be okay. So what happens here is that, yeah, so I've added this rule, right, which is going to be executed very soon. And in this case, because the data is fully matching, I won't have any issues, right? So because, you know, at this point it's the very first run, so there will not be any problem with the data, and I will be happy, so I can move, I can go to production. So now, so it should be okay soonish. So the data is being created, the merge is being done, and then okay, now I have my data. Here, if I reload, I will have my, okay, there we go. So I have my merging between the our data customer CSV, the merger status, which is merging into the customer, and is exactly what I wanted. So if I navigate now to this table, right, to the customer table, we can see that there is a rule that has been added, which is data and rows of all data customer CSV absolute cannot be greater than 0. So basically, we want to make sure that the delta between the input and the output is maintained at 0. Actually, I can show it, and currently the delta is at 0. Okay. Of course, this can also be falsified, and this is the example I will show after. So what is great here is first that we have these lineages being produced automatically from the Python code without any extra information being added to the code besides this rule that we wanted to add from the code. And from the project perspective, I still have one application. The other stuff that I can do too from here, right, is to run an SQL from workflow in order to combine this data together into 360. In order to accelerate a little bit the timeline, so I'm going to show the workflow real quick. So the workflow is just initializing a few data that will tell where the SQL engine is running and what is the name of the project that we want to execute. And then here we have a regular BigQuery job extended with Kensu, which is DOD here. And we have the configuration where we have the query, which is inserting into Customer 360 the selection of the joint between business, contact, and contact here, and customers, right? Only for customer's ID, which is greater than 0. So this piece of SQL, I can execute it. So there is no parameter, so I can execute this SQL, right? And this is simulating the fact that in production, we have this preparation being organized, and it can be done with whatever you have in mind, right? It can be done with Airflow. It can be done by dbt also, because essentially what is important is the fact that it's running in BigQuery, and it has been extended with a DOT methodology, right? So, I mean, it doesn't really matter how this SQL is being performed or scheduled, because this is embedded in the way this is now working at the ground, which simplifies a lot the architecture, to be honest. So now this query is being executed. At some point, what happens is that in here, in this project, I should see a new, there we go. The new application has appeared here, sorry, this one, which is the demo Google BigQuery, right? And you see that both are disconnected, but they should be connected. These applications should be connected, because this application is producing the 3 tables that are being used by this application, right? So it's just a matter of waiting for the application to finish. So it's not finished yet. All the data are being dumped. So at some point, there we go, they will be connected. So now in the project here, we have 2 applications that are connected because there is a link between the application. One is in Python, one in SQL, one is in Python in the Colab machine somewhere, and this one is run by workflow in another environment, maybe even on Google, right? But they are connecting because at the data level, they're using the same instances. So if I go into this application, which is the BigQuery one, you will see that there are the 3 big tables that are being used in order to produce in a join the lineage, the customer 360. So I can navigate to the 360 here. I can show the statistics that are being also produced on the BigQuery table. So I can show, I don't know, the same as earlier, right? So Euribor and rows and marital status. Okay, and here you can see that we have Euribor, we have different values, the max, mean of the data. For marital status, which is a categorical, we have the number of levels, we have the number of rows also, and we have the amount of data in the table. So this is done automatically, right? Because basically we wanted to have lineage activated on the SQL. You wanted to have the capacity to control also the quality of the input and output together, right? It's there, basically. So I didn't show for the input, but if I go back to the application, I can also check the customers, right? I can navigate to it, and then I will see the different data too, right? So what I wanted to show then, right, is what about this job, right, that was constrained to the check and row consistency. So what I will do now is I will use the February data, which is of course wrong, and I will actually re-execute the whole thing as earlier, right? So the code is now okay. So okay. So basically what will happen is that in this table here, which one? Here, this one, this is an export of SAP, as I said, right? So these are just dumps. There will be a new category for the marital status code, right? However, this data here, which has been crafted almost manually, because this is just a drop-down list in an application where people can choose a single married whatever, these are not updated naturally, right? So this is a file that has been crafted at some point, right, but not really updated. So what happens is that this new category, which is available here, is not represented there, right? That means that because we have done an inner join, of course, there will be data left over because they're not matching. And this is why now you see that the collab is reddish, because this function here has raised an n rows consistency error, because this check here is not passing anymore, because the data in customer here, the customer's data is lesser than the data that is read from the file. And you can see that the error is presenting, how much data is failing. So if I go here in this application, I see that there is a ticket for the customer, right? And this ticket, you can see it in this ticket panel that can be shared with ServiceNow, Jira, or whatever, right? So the tickets are generated automatically on the data when they are produced from the application. You can see that customer data source in the application Collab, which is nothing but a notebook, right? Has a problem because the number of the delta is greater than 0, which is in this case 470. I can go directly to the application. I can see that there is a ticket, as I shown earlier, and you see here that there is a bump from 0 in the delta to 470, and there is a ticket assigned to it here. But now, as I said, so we need to be able to perform some root cause analysis, right? So from there, you're on the data, you jump to the application, right? From the application, you can see you can navigate to the other application if you want, right? So that allow you to jump from one application to the other, right? So, and here, I can see in my customer data, choosing my attributes, marital, for instance, and rows, right? That there is something weird happening is that I have 4 categories here. So you see the number of categories for marital is 4 in the first execution. And then we have 5. So you see that it was at 30. Yeah? So it's like 16. So it's the one that we just ran. So we have 470, which is the same amount of problem that we have on the other data set for the new category here. So basically, there is an issue with the marital status, and you want to fix it. So what happens is that, so you discover what kind of issue you have, right? So you can propose solutions. You can discuss with the consumers, etc. Okay, so now the data is not produced in BigQuery. Let me explain why. Because the data has changed, blah, 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 etc., etc. We need to find a solution. We need to contact the SAP people, but before that, can we try to solve the situation differently? I have an ID because I could use an outer join instead of inner join, so that we have all the different information in the table, but there will be null values for the marital status. One consumer would say, I don't care, I don't use the marital status, so go ahead. The other would say, I'm not super fan because I'm using it for segmentation, but I can live without it right at the moment. So please apply this patch, right? So this short-term patch, and then make sure that you can solve the situation as early as possible. So you can go here. So you go in the application, which is producing the data. Where was my code here? So how you want to do the merging is using alter. Okay. So no. And because now you know that you're using alter, right? You want to also be aware of how many null values you have, isn't it? Right. So you want to check also that that there is some no, it's validate. It's at missing value rules. So you want to have a missing value rules, meaning that this rule will check or produce some information about how many data is missing. The parameters are the data source you want to check, right? And how is it actually not how, but it's column, if I remember. It's calls, yes, and we want to check only the marital status. Excuse me. Status. Good. Okay. So here we add the missing value rules for the customer for the column there. Okay. So because we know, and actually, for having been there, so you know that you're creating some values that are nulls, but you want to have some information about how much they're created. And after even you have fixed the situation, right, you still want to know how many null values you'll be producing, because after you have fixed the first time the file, right, maybe it will come again. The 6th category will come. That means that this fix is actually producing no error, because this is not going to it's not only a rule, not a check, right? So it's not going to produce any error, right? So you still want to know when, again, this number of null values is above 0, right? Because it will give you some information about an event that has already happened. So now that the code is updated and I've added my post-mortem activities, which is creating the rule, I'm restarting everything, I'm running everything. Oh, so the new data is produced for February, and we're good to go. So the consumer will be not super happy because there will be missing data. At least one of them will be happy because they don't use the marital status, but the other one will still kind of wait for the full resolution to happen. But in the meantime, they're not blocked anymore, which is, as producers and provider of services, what we want to achieve in a way. So the SQL is running, the production of the BigQuery dump is running. And here, if I go back in there, you will see at some point that we have 2 tickets. So actually what happens is that, excuse me, so we'll go to the, there we go. So we'll go to the data source. You see that there are 2 tickets now on the customer. Why we have 2 tickets is because now not only we have a ticket for the delta, but we have one also for the marital status, right? So the thing is that the ticket for the delta is the one that we wanted to fix here, right? So we go back to 0 now, so we're good. Actually, we can go to tickets and we can go here and fix it, right? So basically applying non-filter out using outer on, right? Nevertheless, I still have this one ticket here for the marital status, no rows that cannot be greater than 0. But as we said, so it's only a check, it's only a rule, not a check. That means that it's not blocking. But still, we have 470 rows here that are nulls, which have been filtered out from the outer. Good. Now, very quickly, what we can do is, okay, now in March, so it took like a month to resolve the situation with the marital status. We have the new version of the marital status referential, right? So in March, we have a new version that is running. So I'm restarting everything again, like simulating an application or in this production, and this is why I'm doing this. There we go. And what happens in this case is that I should have 0 appearing here in the project. So I will let it go. And when it's done, we see together the outcome of this. And then we will be able to fix the issue once again, once for all. There we go, almost there. Okay, so here, navigate, and oh, sorry, actually I should be there. There, this one is still the problem, right? So if I show it, it's still the problem. But if I go to the application, I go here, navigate, and I show okay, this one, huh? So if I show this, the new value is 0, right? So basically we solve the situation. The customer table is no longer having any zeros, right? So this can be also seen here. Choose attributes, this, right? We see that the oh no, actually this is not the one I wanted to show. Actually, marital status delta, sorry, delta here is this one. We had 0, we had this here, and then we dumped into 0 here. Come on, it's going to be easier here. we went from 470 to 0, which is exactly what we wanted to fix. So we can go back to the tickets, we can fix it, and off we go. So basically, the idea is, so of course I can run this demo forever, but basically the idea is to think about the different aspects, pretty much like when we do testing or when we do logging, right? Think about the different corner cases, problems that can happen in production, and embed this kind of checks within the applications. We do this for logging. We do this even for some barrier conditions where we receive an HTTP request that shouldn't have any values in the JSON payload null. We check that these values are not null, right? We do this kind of things for applications that are not data. Why don't we do it for data, right? And because it can be intercepted or intuitively perceived as cumbersome, whatever, but it is not true. With the reasonable amount of abstraction and standardization like we did in these Dart libraries, you can already capture a lot of information that will solve many of the situations naturally without impacting a lot the daily work. So this is, what time is it? So less than 25, so awesome. So this is closing this. So I'm sorry for the hiccups during the first minutes. I'm not sorry about the problem during the live demo because I was expecting them anyway. But it was a pleasure. I don't know if you have any questions, so I'm happy to stay around for your questions. Another thing I wanted to say is that, as I said, so most of the R&D team is in Milano, and we're still hiring a few positions, including system engineers, data architect, consulting person for integrating the product, and others. So please do check our website. And again, so if you want to check out the already report that we wrote about data observability, you can find it out in this link on our website. So thank you a lot for your time and attention. Any questions?
Thank you. Yes, I have a lot of questions, so maybe I can break the ice then. If someone else have a question, please can turn on the microphone and can do the question directly. I see that what you have shown is, to me, a very central part in a data mesh approach of the data product control plane, no? So you have a part of the platform that should be in charge of deploying the data product and monitor the data product in production, and you do that adding and embedding a library, so instrumenting the data product with a library that do most of this work automatically. No, my question is, in your experience, in your view, this kind of approach and also this kind of product, this kind of tool is something that can be applied only in reality that are going to a data mesh approach, or can be something that is applicable also to other reality that maybe even do not treat the data as a product? Because monitoring and automating data quality is something that can be applied everywhere. No, even if you have a legacy integration system, you do not treat the data as a product. You can apply it. It's not as good as data observability as you've shown us today, but it's applicable. Instead, data observability is something only for new approach, data-centric approach like data mesh, or is something that can be also applied to helping modernize the legacy integration system?
Okay, so data mesh. I mean, you know that I love the subject, and I was part of the reviewing team of the Jamak book. So this book is awesome. So she did a great job, to be honest. It's a kind of Bible. What I like the most in data mesh is that she has captured a lot of the best practices gathered over the last 40 years in IT and captured it in a snapshot that is perfectly fitting the conjunction of IT realities and data realities. When I say this is that data mesh, in a way, it can represent everything that is oriented to around data, right? Of course, it's presented in several ways, with the planes and so on and so forth, right? But ultimately, it's a good set of principles. So therefore, what I just presented here can be applied to anything. right? It's just logging, right? It's nothing but logging from the application what is performed, because what we want to do is to know which application we have to maintain in order to resolve a situation, right? A data product is like a superset of an application in a way, right? So it can embed multiple applications, it can be multiple things, right? But representing a certain level of trustability at the product level only. But internally, when you have to maintain the engine below the product, you still have to have some notion of observability also in there, right? To make sure that you are capable of capturing this. So that's why actually, as I said earlier, the very first time I started applying this kind of principle were not when I was doing engineering, it was when I was doing data science. Then I moved towards a bit more engineering. I tried to reuse the same thing, right? And it made all sense. It's just like, okay, I'm going to produce some logs. So what's the big deal? And actually, there is one thing I want to say to close this, is that there is one thing that I like to say, is that a database is nothing but a data application. It's an application, right? It's a piece of code that is accepting requests and producing results, right? So therefore, data observability can be part of the database system themselves. And it actually, if you think about it, it's already part of it. When you send in the query to Oracle or BigQuery, whatever, they give you back the results plus some metadata, right? The metadata including time to time, the number of rows that they have returned, the number of pages that are included in the cursor, right? It's nothing but just observability about what is going on in their engine, nothing more, right? But they could extend it to include also other aspects like distribution and stuff like this, and we would have less to do in order to observe what we do.
This makes sense to me. I have two more questions, and then I leave the stage to the other. The first is technical, is curiosity. When we do the post-mortem and we decide to add a new validation rule to a particular application, we need to write it as a code, or you see that in the future that will be also possible to push the validation rule from the server directly to the application, in order to not rewrite the code, redeploy everything. But I have a new validation rule, and I want from the central server to apply this rule directly to the application.
So it could be done. It could be done now, if you know, right? So basically, you need a server that accepts a request that is going to update the query, right? So the rule. So and to be honest, you can do it also manually in the interface, which is almost similar, right? The thing is, when you update so in order to solve the situation at the post-mortem, right, you had to update the code, right, somehow, right? And that means that even before going to production, you add this piece of line, of code that is pushing the rule. Why it's good, why I feel it's still good, even though we have activated in the product also from the application perspective, right? Why I feel it's good to have the rules in there is to have contextualized information around what is done. So when you read the code, you see the rule in there, right? You don't have to go elsewhere and check, okay, what are the rules, etc. Why have we introduced this? No, it's there, right? And actually there is a commit log also that can be attached to it. It will explain why the heck this line is there, right? So, and again, for me, data observability is there in order to help the people that will have to resolve and prevent the issue to happen again, which are not generally the consumer that are suffering from it, but they're not participating only to these different aspects.
Makes sense. So the code is the source of truth of what's happening in the data product, and then everything is generated from the code. That's a
the extreme, yes. It doesn't mean that we have to close all the doors, so everything is open. But if you want to apply the principles, firmly, yes, that would be the case.
That's interesting, because there is a lot of discussion about contracts, how data contracts on the input port, output port, and are usually just metadata. Then the code can do something else. Instead, generated as this kind of contracts of validation rule directly from the code can be also really interesting, to not have some fork between what I declare and what I really do inside the code. So keep that updated, or have the developer to work on metadata and on code to keep them aligned every time you do a notification. The last question from my side is that you collect a lot of operational metadata, let me say. How do you see the integration with other governance products that maybe manage the more static metadata, for example, the business glossary? Because it can be as interesting to connect the business glossary together with the operational data, because this provides more context and so can help to find the quicker the problem and solve the problem.
Yeah. Everywhere we start deploying data observability, the way we do it, which is like a hub of information, right? It starts becoming also some kind of a hub of control information that can be dispatched, reshaped also to be presented differently at a higher level, like in data catalogs, in dashboards or whatever, right? Where already today there are already some processes to manage the data or the operations in certain fashion, right? So the goal of Kensu is to participate to this adventure by providing as much information to this system so that they can operate also faster, more precisely, and focus on these different aspects where they're super good, and leveraging this information that is coming from the system through these different agents. Yeah. So everywhere we go, there is a binding with the data catalog and a binding with Jira, an ITSM system like ServiceNow at the very least, and something also, like Grafana, whatever, because you can think about something like Kensu, like a Splunk or Prometheus, right? Something like this that is actually capable of massaging the data observability information to resolve situation, but not dashboarding.
Yeah. So the platform is very open, so I can take the metadata and integrate with other metadata that come, I don't know, from a data catalog or business glossary, and so this is your approach to be very open and work also as a hub of metadata, not only a collector of metadata, but also as an hub that can distribute and activate the metadata, pushing them to other systems. Okay.
Yes. So we can focus, that the segregation of responsibility is important, essentially in the architecture, right? And at some point you build a kind of fabric, right, with these components, and this responsibility they can be dedicated to a platform for observability like Kensu, so that we can focus on gathering the information, creating something concrete, standard that can be redistributed easily and efficiently.
Perfect. If there are questions, I leave the stage, or otherwise I have another question. You say that the library part is open source. Talking about all the product, what is open source? What is in the commercial version? How you divide? What is your business model?
So what we want is to push the DOD method. That means that everything that is related to DOD is open source.
Mm-hmm.
Right? So which is gathering the data, computing statistics and everything, because there is no point in, it's like TDD, right? No point in having a JUnit being closed source, right? But there are, fantastic product like Circle CI or Travis or even GitHub Actions that you have to pay for leveraging the value. So that's why everything that's related to DOD is open source, and everything that is related to combining data and monitoring and rules and stuff like that are closed source. Nevertheless, we will open a sandbox version, kind of freemium, in the coming weeks, that allow anyone actually to leverage some of the features of the platform for free, and then before switching to the premium version, which are more dedicated to more elaborated companies.
Yeah, it's clear. No more questions from my side. I think that we are run a little bit late, so I see that people are logging out. So if someone have a question, this is a moment or never, because we are going to finish up for today, to wrap up. So
yeah,
I don't know. I think that there are no more questions, or maybe I don't know. It's just you that posted the link to the book. So, Andy, thank you very much for your time, for the presentation. I think that's super interesting. A lot of ideas, especially for me in the world of data mesh and how to try to put it in practice some way. So it's there are a lot of insight or something on which I have to think about. But I think that the product is really interesting. And so thank you very much for being with us today.
Thanks.
And in the upcoming week, as always, the video recording will be online. I will do a little bit of post-production to solve the problem of the connection.
Oh, yeah, thank you.
But anyway, in a couple of weeks, the video, the recording will be online. So thank you very much, everybody. Have a nice evening, and see you again for the next event. Bye-bye.
Thanks, everyone. Thanks for inviting. Bye-bye.
Bye.
Good evening.